And I'm delighted to have the chance to be here and to present to a sizable audience of what I hope are curious people. As Jim said, I'm a recovering academic. I spent 20 years in academic medicine. I did a fair amount of research in the relationship between diet and physical performance and human well-being. And one of the things I set out to do as a young scientist back when the idea that a ketogenic diet was beneficial for weight loss was, I knew from my training that was probably wrong and that was probably harmful. And so I set out to prove it was wrong and ended up shooting myself in the foot, i.e. I came to the opposite conclusion. And in the process, I basically coined a term, nutritional ketosis. And I want to explain why we felt the need to come up with that term and what it means, and then Dr. Hallberg is going to leverage what I've said to tell you that it may have some clinical significance, not just in the abstract area of academic medicine, but actually in direct patient care. So I'm guessing if I push this button, it'll change the slide. Okay. So what I was taught in medical school is whatever I was taught about ketones was derived from the fact that in medicine at the time, and still to a great extent, most healthcare professionals equate ketones with diabetic ketoacidosis. And in most textbooks still, ketones are referred to as toxic byproducts of fat metabolism. And I want to convince you that that's wrong. And we're not taught the wrong thing on purpose. It's just that science oftentimes takes a while to catch up to the published data. But particularly in the last 5 years, there's been a tremendous awakening in our understanding of what the particular molecule that we humans circulate predominantly when we restrict carbohydrates or starve completely, called beta-hydroxybutyrate, what that does. And I'd like, in the end of 15 minutes, to convince you it has gone from being an ugly duckling to maybe a soaring eagle. So one analogy I like to use, I spent 8 years, I call it my hermit phase in my life, living in rural Vermont, and I heated with wood. And I knew that if I had a pile of big logs, outside my house, that was not very useful for heating my house. It was good wood for next year if I split it and got it in the shed and got it dried, but this year it wasn't useful. If I wanted to heat my house, I had to have split firewood. So we can't, if you think of beta-hydroxybutyrate, which is really a partial breakdown product. So if this is palmitic acid with 16 carbons, you can break that into 4 molecules of beta-hydroxybutyrate. This is no more a toxic byproduct of fat metabolism than firewood is broken logs. This is actually a water-soluble fuel that can be transported across membranes, but it also diffuses across membranes. It's not transporter dependent. It can feed any cell in your body that has a mitochondria. It's not an anaerobic fuel, but it's an excellent aerobic fuel. This is not water-soluble. It has to be transported either bound to albumin or in lipoproteins. You have to have lipoprotein and get it across membranes. It's a complicated thing to use. This is an easy thing to use. So just think metabolically, why do we make this stuff and why do we circulate it? And then the really, really important distinction is that if you had orange juice and a bagel for breakfast, you're going to have circulating beta-hydroxybutyrate levels somewhere down here, about 0.1 millimolar. Realize that your circulating glucose is somewhere between 3.5 and 5 millimolar. So compared to glucose, when you eat carbohydrates, you basically sequential amounts of circulating ketones. But if you limit carbohydrate and keep protein moderate in your diet, you just limit carbs, and we all have different thresholds of tolerability where we get into this range between 0.5 and 3 millimolar, and this is what we call nutritional ketosis. That by eating a diet that meets all your other nutritional needs, it just doesn't have much carbohydrate, and your protein is adequate to maintain mass and function, but not high protein. In this range, this becomes an optimum fuel which flows to muscles and brain, and muscle includes the heart, and can replace much of the body's requirement that normally would be covered by carbohydrate if you're eating a high carbohydrate intake. If you do total starvation for a week or longer, your level will be in the 5 to 7 millimolar. That sounds high, right? But 5 millimolar is up where glucose is. You don't begin to have any evidence for acidosis, that is, the body's bicarbonate buffering system begin to fail until you get above 10 millimolar. And diabetic ketoacidosis, when it comes into the emergency ward and we treat it as an emergency, is in the 15 to 30 millimolar range. So think of 15 to 30, that's 10 times what nutritional ketosis is, and that in turn is 10 times what you, or more of what you have if you're eating a predominantly or a carbohydrate-rich diet. So this is, basically ketone starvation. This is adequate ketones, and this is overdose, and they're distinct metabolic states. But no matter how long you starve, or no matter how long you eat a moderate protein, low carbohydrate diet, you won't go into ketoacidosis unless you have type 1 diabetes and the pancreatic inability to make insulin. So we really need to understand there's a place in between which has a physiological role to play in human fuel flow. And the studies have actually been done in fasting humans where they've looked at the brain utilization, and somebody in a glucose-fed state where they're getting almost 100% of the fuel for the brain. By the way, your brain, no matter what you do with it, whether you're listening or texting under the desk or whatever, your brain a day. It's up to a third of the body's resting energy and uses. And I was taught that the brain is dependent on glucose. 600 calories of carbohydrate per day to feed your brain to keep it alive. And yet, in a person who fasts for a week or longer, the majority of the fuel for the brain, most of it beta hydroxybutyrate and its analog acetoacetate, can provide more than 2/3 of the fuel supply. And it's very likely that this other third of glucose that's used in starvation is not required by the brain. Actually, that's the gluconeogenesis that goes on in spite of the fact that you're starving. And because if it didn't burn it somewhere, it would be toxic. So your brain is not glucose dependent, it's only glucose dependent when you've been consistently eating carbs. And the other thing that I discovered in my research is if you feed somebody a low-carb diet for a week or two, they feel really lousy, have brain fog and feel fuzzy. They have all these symptoms that people say, oh, that's just ketone problems. But if you fast, if you put a person on a ketogenic diet for 3, 4, 5 weeks, they go through an adaptation phase, and not just mental performance and well-being, but physical performance rebound and come back to or above normal. And so there's an adaptation process involved. So you can't do a 3-day or a 1-week or 2-week study and say, oh yeah, I studied that, it didn't work. You have to look critically at the literature. If it's not a study that has people adapted over a duration of many weeks, you're not looking at the physiological impact of that state. So let's put the concept of it, where do we put ketogenic diets on the map of diets? And I like this acronym SAD. The SAD diet is the standard American diet in the States. And we're supposed to eat relatively low fat, and so we're eating about 50% or more of our calories as carbohydrate, and close to half of that is sugar, maybe a third of that is sugar. We don't need a whole lot of protein. It's between 10 and 20% of our daily energy requirement comes from protein. And if you add those two up, then it's about 30% fat. If you go on a Mediterranean diet where you reduce the carbs somewhat, keep protein moderate, you're still getting somewhere in the range of 10 to 20% is protein. You're in about a 30% fat range when you eat that. A paleo diet, at least as written by Professor Warren Cordain, who's one of the few true academic people in the paleo literature. Professor Cordain said, well, you need to eat about 30% as protein, you need to eat about 50% as fat, and then the reason why the carbohydrate here is in the 20 to 30% range is he told me just a few years ago, because Steve, you need that 20% of carbohydrates to feed your brain. So it's a self-determining experiment that if you eat carbs, you got to keep eating carbs. And to cross the divide, you need to get down for a ketogenic diet, you need to get your carbs under about 10% for most people. People vary in their tolerances. It's not a high protein diet because the more protein, if you eat in the 30% protein range here, that protein will drive insulin levels postprandially. Insulin go up, ketone production goes down. So we're talking about a little island here in kind of the macronutrient range. And if you add up 10% or less and up to 20% is protein, the horrifying fact is that 70% of your daily energy requirement has to come from fat. Now, if you want to lose weight and you got a fair amount of fat you want to mobilize, and you mobilize 1,000 calories a day, you don't have to eat that 1,000, it comes from internally. But if you've been on a ketogenic diet and your weight's stable, that fat, if you want to stay in nutritional ketosis, that fat has to come from your diet. So the horrifying fact is upwards of 70% of your calories is fat to do this. So it's a politically incorrect and to some degree culturally difficult thing to do. But the question is, why would one want to do it? The other question we get is, yeah, but it's just all cheese and bacon and sausage and, but this actually can be a very varied diet. Most of people we like to say we give them savory and unctuous in return. But there are a range of foods, and there are visible fats you can add. You have high-fat fruit, that is like avocado. We usually use a lot of vegetables, but low in starchy vegetables. That's not, they're just for bulk and not just something to put cheese sauce on. Also because that's your potassium, magnesium, or nutrients and fiber in the diet. So it's a varied diet. This is not a monotonous regimen. And then the question is, what happens when you do that? Particularly if you eat all that cheese and dairy and meat, you're going to be eating a lot of saturated fat. And so friend, colleague, co-author, and co-founder Dr. Jeff Volek ran a study a number of years back where he took a group of people with, and half of them were randomized to a high carbohydrate, relatively low fat diet that was low in saturated fat, and that was calorie limited at 1,500 calories a day. The other half were told to eat a high fat, low carbohydrate, moderate protein diet and not restrict fat and eat to satiety, and because they were overweight and particularly had central weight excess, they spontaneously ate about 1,500 calories a day, and that's why we chose the energy restricted for the higher carbohydrate intake, because we knew those were two, from our experience, that those would match calorically. So one was eaten to satiety, one was eaten for energy restriction, and you can see they differed remarkably in their macronutrient intakes. But particularly the high-fat diet had 3 times as much saturated fat as the low-fat diet. We measured a whole bunch of parameters that determine metabolic syndrome, our central obesity, low HDL, high triglycerides, insulin resistance. And if you look at the things here that are in green, the red bars are changes in from baseline associated with a high carbohydrate diet, and the changes in blue are with the high fat diet is green and the high carbohydrate diet is blue. And what you can clearly see is that there's about twice as much weight loss. And people say, well, that's all water. No, maybe about 1 kilo out of the 6 kilo difference was glycogen-associated water from muscle and liver. But the abdominal adipose tissue measured by dual X-ray absorptiometry was almost twice as great in the high-fat group. The triglycerides came down nicely with caloric restriction with the relatively high carbohydrate diet, but we got more than double the reduction in triglycerides with the low carbohydrate, high-fat diet. And then HDL went up by over 10%. And by the way, there is no drug that you can safely give to people that will dependably get that kind of response. And that's a consistent response we see when we use a well-formulated ketogenic diet. Blood glucose came down better. Insulin went down dramatically. Now, how does blood glucose go down if the insulin level is going down even more? And the answer is, you get a marked improvement in insulin sensitivity, and it's this lousy measure of doing something called the homeostatic model, which basically uses just fasting insulin and glucose. They're more exacting models. But in a group of 20 people, this clearly indicates that there is a marked improvement in insulin sensitivity in spite of feeding a high-fat diet, which runs against quite a bit of the published animal literature, and I won't get into why that might be. So marked improvements just in 3 months feeding a high saturated fat diet. And I want to expand on this bar over here, and that's on the next slide. So this shows the total saturated fat in the circulating triglycerides in the blood. And so we're actually measuring how much saturated fat is circulating per milliliter of blood. And you can see that the amount of saturated fat in the blood goes down much, much more with the well-formulated ketogenic diet, in spite of the fact that we're eating 3 times as much saturated fat per day for 3 months. So if you were taught the cute little soundbite that you are what you eat, not always. And in this case, you are what you save from what you eat. And what we do when we keto adapt a person over many weeks is they double their body's capacity to burn fat for fuel. And the body appears to prefer to burn saturated fats first. So it becomes basically a disappearing act. You eat it, it's gone. If it doesn't accumulate in your blood and in your tissues, it's not going to cause you harm. So if we get beyond the you are what you eat and get into the kind of the subtleties of this, it's about flux. And we change the flux of fuel fatty acids markedly when we adapt someone to a ketogenic diet. The other fascinating things that have happened just in the last 2 years is we now understand that beta-hydroxybutyrate is not just a fuel. It turns out to be a potent signaling molecule, which in the case of inflammation, downregulates something, and this is like vegetable salad here, NLRP3 inflammasome. And this is a driver of multiple inflammatory pathways in the body, and that is selectively downregulated by beta-hydroxybutyrate. And it's been demonstrated clearly in animal models. So we now have something which is made in the liver from fat, circulates in the blood, and it signals the nucleus of the cell and alters gene expression, and that technically is a hormone. So now it's a fuel, but it is just a potent epigenetic signal. Does that have any effect on inflammation in humans? So in the study that we ran in people with metabolic syndrome, now everybody has their own favorite marker of inflammation. I think IL-6 is important, or IL-1, or TNF-alpha, or CRP, or even old-fashioned white blood cell count. Well, we decided to measure them all. So we measured as many as we could. We measured 14 of them, and 7 of them didn't differ between the 2 groups, the high carbohydrate, low fat, and the high fat, low carbohydrate group. But of the other 7, shown in red for the ketogenic diet, 7 of the 14 were significantly more reduced, had a significantly greater reduction compared to the high carbohydrate, low fat diet. And we've seen this consistently now in 3 human studies, that when we do the diet properly, we actually get people into nutritional ketosis, not just low carb, but in nutritional ketosis, we see a potent anti-inflammatory effect. The other striking observation was made by a number of groups. Well, one of them was Eric Verdin's group when he was at UCSF, University of California, San Francisco. He published this in Science in January of 2013, and that is when you infuse beta-hydroxybutyrate into mice, even in the short term, you downregulate a group of enzymes called histone deacetylases, a group called the class 1 histone deacetylases. These are gene silencing enzymes. So when the enzymes are active, they turn off genes, and the class 1s, for whatever reason, turn off our internal message or our internal capability of antioxidant defense. So when you don't have ketones circulating, your antioxidant defenses are turned off. When you have ketones, it downregulates the silencing enzymes and turns on endogenous antioxidant defense. And in this paper in Science they published, they clearly demonstrated that actually hydroxynonenal, which is a biomarker of lipid peroxidation, and also directly measuring oxylipids in the liver, were significantly reduced in the presence of beta-hydroxybutyrate. So we have a separate signaling mechanism, one for inflammation, one for oxidative stress. Oxidative stress translates into, people think, longevity. So on the study of longevity, and this nematode called C. elegans, which only lives for 20 days, it's a darling of the longevity research community, because if it only lives 20 days, you can do a whole study in a month. You know, if you want to do a study in humans, it'll take 110 years. You know, mice about 5 years. So it's a quick and simple way. And when you grow these C. elegans on algae that they grow when they eat bacteria off the surface, if you grow them in the presence of beta-hydroxybutyrate and you get the dose right, now here's the dose, you say, oh no, that's 20 millimolar. That's ketoacidosis. But they're sitting on top, it's the worm sitting on top of the algae. It's got to diffuse up through the cuticle into the worm and achieve a tissue level. And we have to get to 20 millimolar but have enough gradient to get it in there. They live 25% longer. This is about the same amount of time that longer that they live if you give them some of the drugs that are known to increase longevity in worms. But then these are just lowly worms. And how about mammals? So a group at University of California, Davis, John Ramsey's group, didn't publish. They presented this data back in September. I believe the paper was submitted. And so, since it's pending publication, don't take a picture of it. But they did a study, a 3-arm study with mice in a pathogen-free environment under carefully controlled conditions, and they grew them on a controlled diet, which is standard mouse chow, on a low-carb diet that was 20% of calories as carbs, and therefore not ketogenic, and then on an overtly ketogenic diet for the mice. And you can see the growth curves here that as you get out past 900 days, the ketogenic animals are the ones that live the longest. The low carb are not don't get the same effect, but there is a statistically significant difference between the control group and the ketogenic group, and there's the 13% increase in longevity. So this is getting the attention of people who think that longevity is important. But then, living longer if you're miserable and weak and malnourished is a lousy thing to do to someone. So what happens to the function of these mice? So here in the upper left-hand corner, in the ketogenic diet animals at 1 year into the study, and then at 900 days, or almost 3 years in the diet, the ketones were consistently higher for that. It was a ketogenic diet. This shows time to notice a novel object introduced into the cage. This is a measure of mental acuity in the mouse. And both the low carb and the control animals had significant reductions in their ability to see a novel object in the cage, and the ketogenic animals had no reduction in the ability to see novel objects in the cage at 900 days. Rearing score, that is the ability to rear up and stay on hind legs, so it's a measure of balance. And so not only do the mice live longer, but at the advanced age, they maintain more useful physical characteristics, which I find intriguing. If 3 or 4 years ago we wouldn't have a mechanism, and now we think we actually understand some of the key aspects of the mechanism of how that works. So back in the 1960s and early 70s, people figured out that fat could be mobilized to the liver, make ketones feed the brain. Now we know that we markedly change fuel flow to muscle. Present the data on airway inflammation, but the data is out there in an animal model, the longevity with the nematodes and now with humans, and reduction in oxidative stress are all end products of this loaded little ketone molecule.